First video for the January 30th class is going to continue our exploration into Excel. And in particular, going to dive a bit deeper into functions. You'll recall last week we learned one that was a particular complex function, but an important one to start with, which was VLOOKUP. The ability to sort of take multiple different data sets and join them together to make one complete data set. But we're going to learn a couple more, I think, really important ones, all of which tie into the broader goal of helping us make data that we've downloaded or pulled into Excel more manageable, easier to read, and ultimately more complete for us to analyze. And functions in Excel are controlled by the equal function. So you could type in any cell and put equal, and type a letter, and you could see sort of the variety of functions that you would have at your disposal. And I certainly encourage those who have enjoyed last week and this week and sort of see the potential and importance of Excel as a tabular data management tool to definitely explore. But I wanted to teach you these ones here because I find these to be pretty useful for basic data management and to support analytics. And I think having these at your disposal will really help you be able to navigate almost any piece of data you get. And I think that's going to be a common theme this semester is you may find a piece of data that theoretically shows you what you want, but that doesn't seem to be working. Fields aren't joining because they're different types, or someone organized data in a weird way that you want in multiple columns, but it's only in one column, or there's a pattern in the data. Something is coded a certain way that if you could just manipulate each piece in the same way, the code would extract itself. And that's what we're going to go through today. So each one of these for this first video corresponds to sort of phrases on the left, and I'll kind of demo each one in this D column. And when I do so, you should be able to sort of visualize, and then I'll provide this workbook obviously for the week so you can follow along if you want. Okay, so I'm going to quickly step over to I here and just remind us of sort of mathematical functions, right? 1 + 1 = 2. 1 times 7 equals 7. The max of 1, 2, 5, 6, 0 would be 6. Any of those you've learned. Mean, be average in Excel, average, median, min. All of those arithmetic functions you can utilize. And hopefully enough of that is still in your brain from whenever you first learned Excel, that it's not too complex to connect the dots. But these functions I'm going to show you here often work with text based Excel operations, and as such they're not taught as widely, and so that's when I make sure you can use them. So the first two here, and concatenate, they're all about bringing together multiple pieces of data, right? For example, if I were to simply say you and you, I'm clicking on a cell, it would literally merge them together. And the neat thing about and is you can put anything you want in between them. You and put a quote, a space, and a quote. See, that's actually a space in there. And you, right? And it'll follow it and put them together. Jefferson and cheese, 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 and you would produce that. That's and. A tool very similar to that is concatenate. Only difference with concatenate is you're just dragging together any of the things you want to smush up. Why is my concatenate not working? What should do to me? 1, 2. And maybe I can't drag. Maybe that was the problem. I have to do continued sort of commas to put them together. But it roughly is the same thing. It allows you to sort of put multiple things together and drag them. That's concatenate. So the purpose of those, taking text that's in multiple different columns and pushing it together in one. Next one is replace. Now replace is certainly a common one that when we start calculating fields and managing data in Arc Pro, we're going to use even more. It's not the most friendly tool in Excel. You'll see in a second it's sort of counterintuitive with how you'd want it to work. But it's a helpful function, right? It allows you to sort of take some element of a text phrase and replace it with something that's more meaningful to you. So equals replace, and like any function, you have sort of what it's looking for. And the first thing it wants is like, hey, what am I replacing? Okay, well, we're replacing something in the word tuna fish. Now here's where it gets a little annoying. Start number. What that means is it's asking you, where do you want to start? Right? If t is at 0.1, u is 2, n is 3, a is 4, space is 5, that's ultimately how this works. You need to say the point. So, right, if we wanted to replace the word fish with melt, turn tuna fish into tuna melt, well, I can see that the f is at 0.6, right? T is 1, u is 2, n is 3, a is 4, space is 5, f would be 6. So I can say start at 6 and do 4 characters, right? 6, 7, 8, 9. And place it with what? Well, we'll make the new word melt. So again, it's not the most intuitive, right? What you'd want it to do and what make more sense to you might be to have it structured such that you're replacing some piece of old text with a new, but it really wants you to tell it where you're starting and how many characters, and that's how you'd get to sort of tuna and melt. So in a couple, we'll briefly sort of see this thing called find, which is a nice complement to replace. Sort of helps you find, where exactly in the position of text is a certain character that you might be replacing. So the next ones, int and text, are really important because they're all about data form. Now notice I have two what appear to be equal elements right here, 5, 6, 7, 8, and 5, 6, 7, 8. But you can notice there's sort of a difference, right? This one's justified to the left, this one to the right. This has this little green space up here. And you can see that if I asked these to equal each other, it would tell me that they're false. They don't equal each other. Well, it's confusing because they look like they match perfectly. You'd want to do a VLOOKUP and bring these two together, but it wouldn't work. And this comes back to something we briefly talked about during our first in-person week about the concept of different types of data and different forms of information. That sometimes you have a text and a string and such. And it'll happen all the time, and it is the bane of trying to join. No matter how similar two things look, if one is a text and one is an integer, they won't join. So you need to fix that, and you can do it pretty easily. You can do it by doing an int. So let's take this text and make it an int. And there you go. It's an integer, right? I've changed its form from text. It's now not putting quotes around it behind the scenes. It's turning it into an integer. And I can do the same thing to the other one by doing text. Now, the only difference with text is you tend to put the 0 at the end. I'm not exactly sure why, but the double quote, 0, double quote just sort of formats it in basic text, and you can see it went over here to the left and formatted itself as text. So not too complex, this concept of int and text, but they're useful tools that we'll return to again in Field Calculator, and they're really used when you get stuck in this situation where something's an integer but you need it to be string text, or vice versa, something's a text and you need it to be an integer. Next is left and right. Great tool. Really all this is asking you, if you say left, is effectively take a piece of text like the word San Francisco here, and let's just bring back the first X. Right? Well, maybe I want this to just be San, right? And so I'll say, let's take the first 3. So left, 1, 2, 3, it brings back just San. And I can start to string that together with other things, right? Take the left, 3, and maybe add the word space Diego, right? So I've switched you from San Francisco to San Diego. Right, as I'm sure you can figure out, is just the opposite. In this instance, you're moving from the right of something, right? So maybe I want to have Francisco, which appears to be, I think, 9. I may have miscounted that, but right 9, and there you go, Francisco. So left and right, often used when you have large pieces of text where you're trying to get segments of them out, moving from one side or the other. Upper, lower, and proper. Related to int and text, not at all in what they do, but in maybe what the goal is. This might not be apparent yet, but we're going to get to the point where you'll see these two words are identical, supercalifragilisticexpialidocious. But they don't equal each other, they'd never match, they'd never join, and they'd never look up. And it's because one is all lowercase and one is all uppercase. And the point I'm trying to draw here is the same way that an integer needs to be an integer and a text needs to be a text. When you're joining or trying to match or look up words, They must be in the same case, and all of them must be. Now, good practice is that everything should just be upper, but let me just show you kind of how to do this. It's pretty simple. Hey, upper, U, and everything goes to upper. Or I could take lower, do the one below it, or I'll go to lower. Or even better, I could do proper, and it would just capitalize each individual word, right? I mean, maybe that would work better here for the Carmen Sandiego. Proper, where in the sentence, you'll notice it takes where in this sentence is, right? It proper just makes every first letter after any space a capital. Len is all about finding out how long something is. Right? So sometimes you might want to set up an equation that, maybe something's been set up to have the name of something and then it's like ID behind it. And you just want the name to come out. And so you're thinking, okay, maybe I'll use, a left, but it, couldn't really do it because they all have different sort of lengths, and then the codes behind them are of different sizes. And so you can use len to really find out how sort of long something is. And once you know how long something is, you know sort of how you might want to cut it up, or what the first character, what the second character might be. All right, so that's all len does, right? Len helps us understand how long. That's 34 characters long. That's the purpose of len. Find, I sort of referenced briefly when I talked about replace. The whole concept of that is that we'd use something like find to say, all right, well, where in the sentence is Carmen Sandiego? Okay, well, I'd say find the word, find Carmen within this. Carmen begins at 27, right? So what it's telling me here is that however long this thing is, at character point 27 is where the word Carmen begins, right? So that can be helpful and useful, and then you could turn that back into replace, right? If we know it sort of starts at the Carmen there, I could add that into my replace to replace that word. Definitely one of the most important ones that we'll learn a follow-up to when we do field calculator is this idea of text to columns. In the follow-up video, we're gonna sort of execute this in a more practical context. But often you'll find data that is organized not in a way you want. The general rule when you're working with any kind of table, whether it is Excel, whether it's a DBF, whether it's ARC, is that you want separate pieces of information in separate fields. And so what I mean by that, and I'm going to copy this one down here so we don't run into any problems, is this is trying to tell me an address, right? The address, the city, the state. But the challenge is it's all in one column. And, we'll get to a point a little bit later when maybe we want to run some analytics and summarize by different states and summarize by different cities. That's going to be impossible when it's all sort of in the same area here, right? Because, let's say I had a thing that was 123 Cheese Street, Philadelphia, PA, 129 Donkey Street, Philadelphia, PA. And I wanted to analyze these and other pieces of data and see how many were in Philly. Well, I wouldn't be able to do it with this because even though both of these are in Philly and I know they should join themselves together and show me as being from the same place, their records are different because the address is in the front. These are totally different sort of values here. Versus if I had a whole field that was just my city, right, I could see that these two definitely were one and the same. And so this isn't always easy to figure out, but oftentimes the data will be helpful in such a way that you can see, comma, what it's telling you here is effectively I have a pattern. There is a comma in front of every new individual piece of data. And you'd solve this by clicking on it and going to data. And now again, this may be an instance where it's in a different place for you. So if it's not here on the Windows, I would sort of go to search the question mark and try to figure out exactly where text to columns is and click on it. Typically, you're going to do delimited, meaning I'm going to give you a character and then you split at that character. What's my character? Well, let's pick comma. And notice it's even putting lines where it says it finds. It says, look, I found a sort of comma here, and that's how I'd break it. next, finish, and there you go. Boom, boom, boom. Now, always be careful using this tool because as you can see, it overwrites whatever's to the right of it. And that's why I didn't want to do it here at first, because you don't want it to accidentally overwrite any data you're working with. So the last one I'm going to fix is related same to upper and in text, in that this is a helpful tool when things aren't joining or don't look the same. So the concept of trim is removing of white space. Now, it's easy to conceive of white space when it precedes something, right? Okay, it's very clear that when I wrote that word, I put spaces in front, right? Space, 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 Shay would look like that. And I can remove that because, right, if I wanted to join that to the word, how do I fix this? They look exactly alike to us, but they do not equal each other because this is preceded by more characters, right? Hey, how long are you? Oh, you're 26. Hey, how long are you? Oh, you're 18. What? Oh, I see. You have a bunch of spaces. Anything you type on a keyboard is a character. And white space is easy to get rid of by trim. So I would simply say, hey, trim, boom, and there it is, right? It trims away all the pieces. Trim can be harder to identify when it's on the back end, right? These look almost identical. But no matter how many times I try to join them, U equals U, false. Well, it's because when I wrote the word this here, 1, 2, 3, invisible to you and me, but it's stored in the data. And I would need to do something around the lines of trim, right? I'm saying, hey, get rid of any white space you have here. And then if I were to say, hey, do U equal U? Yep, 100%, right? We trimmed away that white space, and now I look the same. So, only a handful of the many functions you may find in Excel, but important ones, and a couple of which we're going to put to the test in the next video as we access a piece of data that we might find and try to prepare it so that we can better analyze certain trends within it using a pivot table.